right, we're looking at day 113. This is our first day on patterns. We do 1 day on patterns, and then we come back and the next 2 days will be on actually like plotting coordinates on a coordinate plane. And then we come back, our last day of new material is coming back to the patterns, and we're going to be plotting patterns on a coordinate plane. So X and Y, like all the X coordinates follow a pattern, all the Y coordinates follow a pattern. So this is really setting us up for that. Looking at our first example, well, first we'll talk about like what the vocabulary is that we're going to use today. A sequence is a number of a list of numbers that follow a certain pattern, and a term is one of the numbers in that sequence. And so we can talk about like the first term, the second term, the third term. That would be the first number in the pattern, second number, third number, fourth number, right? And so like let's look at this first example. Identify the pattern, then write the next 3 terms in that sequence. So I'm looking at from 2 to 6, and then 6 to 10, and 10 to 14. Like how could I determine the change between these? So like I can try, let's see if this is multiplication. 2 times 3 is 6, 6 times 3 is 18. Oops, that's not 10. So it can't be multiplication. I see that the numbers are getting bigger, and so let me try addition. 2 plus what number is 6? Well, 2 plus 4 is 6. Great. And 6 plus 4 is 10. Great. And 10 plus 4 is 14. Great. So what that means is that the change between each one of these numbers is add 4, right? And the change always has to be the same between the numbers. We can't say like add 4, add 8, add 12, right? We always are adding 4, multiplying by the same number, dividing by the same number, subtracting the same number. So the next 3 terms will be 14 plus 4 is 18, plus 4 is 22, plus 4 is 26. Okay. Let's look at the next one then. David and Samira both thought of 5 numbers. David's first number was 0, and Samira's first number was 0. David added 4 each time to get the other numbers. Samira added 8 each time to get her other numbers. Which statement is correct? The student work that we want here is actually to create a table. And this table I've labeled with David and Samira. And then I've made it vertical, right? And so their first number is 0 and 0. And then David adds 4 each time. So let's go ahead and add 4. 0 plus 4 is 4, plus 4 is 8, plus 4 is 12, plus 4 is 16. I'm realizing now we don't actually need the 6th term here because it just has 5 numbers. Samira added 8 each time. So 8, 16, 24, 32. Right, and what's nice about this is this table lets you see all of David's and all of Samira's, and lets you see the relationship between David's terms and like for his first term and his second term and his third term, but it also lets you see the relationship between David's second term and Samira's second term, or David's fourth term and Samira's fourth term. And like this is how we're going to have students do their work when we actually graph coordinate like patterns on the coordinate plane. So that's why we want to start it today. And then let's just look at our answer choices. David's second number was 8. Nope, that's not true. David's second number was 4. This is a distractor because Samira's second number was 8, right? And like that's why we want to keep our work organized in a table. Samira's third number was 16. Yes, that's true. David's fourth number was 12. Yes, that's true. Samira's fifth number was 24. No, that's not true. David's third number was twice as large as Samira's third number. And so like here again, we're getting into some of that comparison work. Let's look at our third numbers. Is David's third number twice as large as Samira's third number? No, it's the opposite. Samira's number is twice as large as David's. Samira's fourth number is twice as large as David's fourth number. Yes, I know that's true because 12 times 2 is 24. Great. And then like stamp the understanding here for students. Like what was the strategy that I used to show my work in this problem? The strategy that I use to show my work is to make a table. Great, so when we don't actually see the terms, we have to make a table to show what all the terms are. Great. Let's look at this next one. This is the first time that kids will ever have seen input and output tables. We don't want to call it a function yet because we're going to get into functions more in 6th grade. But we can have an input and then like know that some rule applies to that number and then get an output. And so I like to think about it as this, like we put some number in, we apply this rule to it. So like whatever multiplication, addition, subtraction, or whatever combination, and then we get this number output, right? And so like still thinking about like a function machine, we just won't call it a function yet. We're dealing with so many other new vocabulary in this lesson that function is just not going to stick with kids on this day. All right, so rule number 1 would be to multiply the input by 4 and then subtract 2. Rule number 2 is to multiply the input by 2 and then add 6. And so which input and output table works for both rules? What I actually did here on the student copy that you now have, I've switched answer A and C because I don't want the first answer to also be like the correct answer, because then kids will like check out. And so what we want to do here is like, actually let's plug both inputs into our rules and see if that's true. So I'll start here with answer C, which will be the new answer A. 4 times 6, which is my input, minus 2. And then I get 24 minus 2 is 22. That's not 18. So 22 is not equal to 18. My input is not equal to my output once I assign the rule. And so that can't be true. Now let's look at B, then C, then D, right? And so we'll just, I like to put a check mark when it works, right? So B works for the first one, but does it work for the second? No, because 18 is not equal to 22. Okay.